Now, for the next question, we've got this thing. We've got this situation here of, a rectangular box with some corners cut out, and we're going to do some stuff. When I was doing year 11 methods, they loved this type of question. It used to come up all the time. It's kind of gone out of favor, but it's still a good question. Anyhow, box is made by cutting off square corners, lengths of X, rectangular piece of cardboard, 48 in width, 96 in length. Flaps are folded to make up the cardboard box. So, firstly, so this is what it looks like. So what we do is we cut these things out, and then this part here folds upwards, this part here folds upwards, this folds upwards, this folds upwards. So we end up with a box. All right, without a lid. So express the width in terms of X. So we got to check our information. So our width tells us it's 48 centimeters. So we've got, in CAS, I'm going to close this so I don't mess up anything. I'm going to say our width is 48 centimeters. 48, oops, minus, and I've got, but I'm cutting off one X and then another X, so minus 2X. So that's the width. The length, which is tells us the length is 96. So I'm going to do 96. Once again, 6 isn't working. Minus X here and X here, so it's 2X. 2X. Okay. Now find the expression for the volume of the box, not necessary to expand. So our volume is the area times by the height. So if we've got our area, so this is our area, this times this, and then if we're folding up these four sides, we've got a height of X. So this ends up being, we'll say we've got, we need to define it. And find the expression, set the allowable values. So what we'll do is we'll say X times, we're going to open a set of brackets, times, and open another set of brackets over here. I'm going to press the up arrow key. Going to go across, going to press the up arrow key. For that, I'm pressing enter, and that's what I end up with. This would be accepted, and so should this be accepted. So you don't need to expand, but if you're typing it into CAS just to make life easier for yourself, either one of those should be fine. Okay, so that's the volume. State the allowable values of X. Basically, what they're asking for there is the domain. Because what's going to happen is there's going to be some values of X you can't have. So let's have a look at what they might be. So let's define this. Define the, v of X equals this. Looking at it though, what do you think some of the allowable values of X might be? I think it's going to be between, well, we want basically where this ends up being 0. This will end up being 0 if X was 24, or if X was 48. But let's have a look. So we've defined it. So I think it's got something to do with 24 and 48. But let's have a look. Menu, not menu. Home. We're going to graph that thing. V of X. Oh, that's not good. Let's zoom right out. Windows settings. We'll try -2 out to 100. Just see what we've got. -10. We'll go out to 100 as well. Let's see what that looks like. That's ridiculous. Let's keep zooming out. So all I'm doing, I'm just zooming out now. Got a horrible graph. So now I'm looking at, have I entered that incorrectly? We're going to have values of 28 times 24, 48 times 24, which are massive, and then we're going to have a 4 there as well. Okay, so we're looking at values 28, 48 times 24. I'm going to multiply that by 4 as well, so I'm into the thousands. Okay, so I've got to change my window. Analyze graph. No, sorry, that was my phone. So once again, I'm saying x max, x min of say -10, x max of say 50, a y minimum of say -10, and a maximum of what would it end up going to? We'll go to 5,000. Okay, now we're starting to get somewhere. So, what was this? 4608. Let's keep going. Let's go out even further. So, go to 10,000. Still, we've got to go further. Ah, so it's 1,000. Sorry, my mistake. Left out a 0. Go in further. Menu. Window. Let's go to 20,000. Okay, let's go to 25,000. Alright, so there's my graph. I'm going to change the bottom as well. So rather than going to -10, I'm going to go -1,000. And hopefully that'll be okay. Okay, so there we're seeing what's going on then. Okay, so based on this, question wants to know, find an expression, so state the allowable values of x. So basically what we want where we're actually going to have a volume, which is this section of the graph here. That's a positive volume. Over here, we've got a negative one. You can't have negative volume. You can only have positive. So what we're going to do, we're going to look at analyze. We're going to say, where is the 0? Uh-oh. All right. So Windows, no, analyze 0, and there and there. Set 0 and 0. Menu, analyze 0 between there and there. So it's 24. And this one I reckon over here be 48. Let's just check that. 0 and 48. Okay. Alright, so for this one, the allowable values of x happen between 0 and 24, and we're not including those. Because if we include 0, because looking at our function, if we include 0, we don't have a volume. If we include 24, we don't have a volume. So we've got to write it so our values are 0 to 24. So that's our allowable values. Okay, find the volume when x equals 5. That's straightforward. That is v of 5. There we have our volume. Find the answer each which create a maximum value for the box. Give it to one decimal place. So f max, we saw this earlier, f max of v of x, sign for x, infinite. Oh, that's right, because it's not over specified domain. Okay, let's just do it on CAS. Sorry, let's just grab it. So we're going to find where the maximum is. Menu, analyze, maximum between here and here, 10.1. So it happens at 10.1. So that's what we can see there. Now that's a bit weird. It's 2.13 by 10 to the power of 4. So what we'll do is the maximum volume. So we know what happens at 10.1. So we'll say v of 10.1. Close that off. Enter, and that's what we get as our maximum volume. So that's about it. That's all we have to do for that question.